بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Calculus 2 first major last semester 2023. Let us solve it together. The first question, evaluate the integral. We have three integrals. So let us think of the first one. We have x, we have 1 plus x squared. So the derivative of 1 plus x squared is 2x. So I can just multiply by 2 in the numerator and outside. And I can call u equals 1 plus x squared. So the derivative du would be derivative of 1 is 0, derivative of x squared is 2x dx. And now the integral would be, if I call this integral I would be equal to, there is a half outside. Now 2x dx in the numerator is du, and 1 plus x squared in the denominator is u, and the integral of 1 over u is ln absolute value of u plus c, and u is 1 plus x squared. So that's the first, the answer of the first part. Well, here I have 1 plus x squared, I have 7 there. The derivative of 1 plus x squared is not in the numerator, but there is a formula that says integral of 1 over 1 plus x squared dx is tan inverse. So this 7, I can take it out because it's a constant. And the answer would be 7. The integral of 1 over 1 plus x squared is tan inverse x plus c. Well, here I have, there are 4 parts. Okay, here I have 2 to the power x squared in the denominator and x in the numerator. Well, the derivative of x squared is 2x. So if I take, let me first write it as integral x times, I'll bring this up. So 2 to the power negative x squared dx. When you bring something up, you just multiply the power by negative sign. Also, when you bring it down. Now, the derivative of negative x squared is negative 2x. So it's okay. I can multiply by negative 2 inside and divide by 1 over negative 2 outside. And I can take u equals negative x squared. So du would be, derivative would be negative 2x dx, which is this one. So this integral would be written as negative half. Negative 2x dx is du, and negative x squared is u. Now, what is the integral of 2 to the power u? It is 2 to the power u over ln 2. So the final answer would be negative half 2 to the power negative x squared over ln 2 plus c, because u is negative x squared. Well, here I have square root of x inside secant square, and derivative of square root of x is 1 over 2 square root of x. So I need 2 here. So I will multiply by 2 outside. So 2 over 2 would be 1. And I'll call u square root of x. So the derivative du would be 1 over 2 square root of x dx. So it would be 2 times. Now, 1 over 2 square root of x dx is du. And secant square x would be secant square u. Now, what is the integral of secant square? It is tan, because the derivative of tan is secant square. So the final answer would be 2 tan square root of x plus c, because u is square root of x. Well, this is the last part. So question 2, find an expression for the area under the graph of this function. Well, the area is defined to be the limit when n goes to infinity of summation I from 1 to n, f of xi times dx. This is the definition of the area. And delta x is defined to be b minus a over n. So 1, 3, so 3 minus 1 is 2. So delta x is 2 over n. xi is defined to be a, which is 1, plus I times delta x, so 2I over n. So I can write the area as limit n goes to infinity, summation I from 1 to n. Okay. F of xi, well, this is xi. So to find f of xi, I replace x by xi. So I'll have square root of xi, or I can just write the definition. Xi is 1 plus 2i over n plus ln x, which is xi, I replace it by xi, which is 1 plus 2i over n. So all of this is f of xi times delta x, which is 2 over n. Do not evaluate the limit. So just express area as a limit. So that's the answer. Evaluate this integral by interpreting it in terms of areas. So the function inside the integral is square root of 9 minus x squared. If you square both sides and bring x squared to the left-hand side, you notice that the graph is a circle. The center of this circle is 0, 0, and the radius is square root of 9, which is 3. So to sketch the graph of the circle, you start from the center and you go 3 units everywhere. But this would be the graph of all the circle. But here I have y equals plus square root of 9 minus x squared. So y is positive. So in fact, this is the graph of the function y equals square root of 9 minus x squared. It's half a circle, okay? The graph is half a circle. From negative 3 to 3. So this integral from negative 3 to 3 of this function is in fact represented by this area. And this area is half a circle. So the integral, this integral, which let me call it I. So I would be equal to the area, this area, okay, this area. And the area is half a circle. Well, the area of the circle is pi r squared. So r is 3, so it's 9 pi. That's the area of all the circle. But I need half of the circle. So the answer is 9 pi over 2. Find an area of the shaded region. Well, we look for the two curves. We have x equals y, and this is x equals 1 over y squared. This region now, do we have a graph which is to the right of the other graph always, or a graph which is above the other one always? Of course, this line is not above a specific graph. It's above this one up to here and above the other one up to there. So it's easier here to use a horizontal rectangle. Always this line would be to the right of this curve in this region. So the width of this rectangle is this part, and this part is part of y-axis, so it's dy. So the area here would be in terms of y. So I'll have dy. And now y runs from where to where? Well, this is 1 to 2. So y is from 1 to 2. And now the length of the rectangle, okay? So the length of the rectangle would be this point minus this point. So this point x equals to y. So it's y, because I need everything in terms of y, minus the other one, 1 over y squared. So that's it. Y minus 1 over y squared dy from 1 to 2. This will give you the area. Well, he said find the area. Okay, so let us evaluate the integral. The integral of y is y squared over 2 from 1 to 2. What is the integral of 1 over y squared? Well, you know that the derivative of 1 over x is negative 1 over x squared. So in fact, the integral of negative 1 over x squared is 1 over x. So this would be 1 plus 1 over y from 1 to 2. So I have 4 over 2, which is 2, minus a half. That's the first one. And the second one, 1 over 2 minus 1. Well, this is 3 over 2, and this is negative half. So 2 over 2 or 1, the answer is 1. I have an integral and I need to find the derivative. Well, the fundamental theorem of calculus teaches me how to find the derivative of the integral, and it says that you replace t by by x here. But if you don't have x, you have a function, then y prime would be equal to, you replace t by the function here, okay, minus 8 over 1 over x. Well, 8 over 1 over x, x will go up, it would be 8x. Okay, so here we replaced t by 1 over x. But since it's 1 over x, it's a function, you need to multiply by the derivative of that function, which is negative 1 over x squared. So this would be the derivative of the integral, according to the fundamental theorem of calculus. Find the average value of this function. Well, I know the definition of the average value, but the function, if I look to the function carefully, I can distribute, I can write it 2x squared over x plus 5x over x. So x squared with x, I'll have 1x up, and x with x cancels. So in fact, this function is just 2x plus 5. And you can see the interval from 1 to 3, so the function is defined from 1 to 3. This function is not defined only at 0, and 0 is not in the interval. So this is the function I need to work with, and the definition of f average is 1 over b minus a, so 3 minus 1, that's 2, integral from 1 to 3 of the function f of x, which is 2x plus 5 dx. So the integral of 2x is 2x squared over 2, which is x squared, plus 5x from 1 to 3. If you replace x by 3, 9, plus 15, that's 24. If you replace x by 1, 1 plus 5, that's 6. 24 minus 6 is 18 over 2, that's 9. So this is the average value of the function on the interval 1 to 3. Determine the values of c that satisfies the mean value theorem. Well, the mean value theorem says f of c equals f average. So what is f of c? This is f of x. I replace x by c, so I'll have 2c plus 5. That's what? That's f of c. Equals f average, which we evaluated, 9. So 2c would be, take 5 to the other side, 9 minus 5 is 4, divide by 2, so c is 2, And finally, notice that 2 is in the interval 1, 2, 3, inside the interval. So this proves that your answer is correct. Okay, it's inside the interval. Sketch the region bounded by the curves, these curves, and set up an integral to represent the volume of the resulting solid. Okay, this is y equals square root of x minus 1. Well, I know the graph of y equals square root of x. It's like this. What does minus 1 change? It takes the graph 1 unit to the right. So the graph would be like this. Okay. Now, this is the graph of y equals square root of x minus 1. This is 1, 2, 3. Also, x equals to 3. This is this line, the vertical line, x equals to 3, and y equals to 0 is the x-axis. So it's this region. This is the region enclosed by all these curves. We need, okay, the region bounded by the curves and to represent the volume of the resulting solid if it is rotated about the y-axis. This is what I was searching about. The rotation is about the y-axis. Using x as the variable of integration. X as the variable of integration means we have dx here. This is the meaning of this. X as the variable of the integration. So you have the integral with respect to x, dx. To use dx here, the width of the rectangle should be dx. So this means that the rectangle should be a vertical rectangle. So the width is dx. And if I have a vertical rectangle, it's parallel to the y-axis, the axis of rotation. So I should use here cylindrical shells. Now, the formula for cylindrical shells is V equals 2 pi x f of x dx. That's the formula. X from where to where? Well, this is 1 and this is 3. So x is from 1 to 3. This x is the radius of the shell, and the radius is this distance from here to here. And this distance is on the x-axis, so it's x. We call it x. F of x is the height of the rectangle, and the height of this rectangle is the y of this function, because this is a point xy. So this function is square root of x minus 1. So I can just replace f of x by square root of x minus 1. This will give you the volume. Okay. Y as the variable of integration. If y is the variable of the integration, then the volume would be, he said set up, he said don't evaluate. Okay. So I should have dy here. This is the meaning of y being the variable of integration. If I have to use dy, then the width of the rectangle should be dy. So the rectangle should be a horizontal rectangle. So the width of the rectangle is dy. And in this case, the rectangle is perpendicular to the axis of rotation. So you should use here disk and washers. If you rotate this rectangle around the y-axis, you will get a washer. The formula for the washer, pi outer radius square minus inner radius square. Well, y from where to where? Y starts from here, from 0 to this point, to this point. Well, what is this point? Well, this function is y equals square root of x minus 1, and here x equals to 3. So if I replace x by 3, because this point here x is 3, so 3 minus 1 is 2, so y is a square root of 2. What is the outer radius? Well, the outer radius is the distance from here to here. Okay, because when you rotate this rectangle, this is the outer radius. And you can see that this distance is fixed, and it's always equals to 3. So 3 square would be 9 minus inner radius square. Inner radius is from here to here. And from here to here, this is x of this function. Well, this function is y equals the square root of x minus 1. So I need to solve it for x. So I'll have y squared, if you square both sides, equals x minus 1. And then x would be y squared plus 1. And this is the radius, outer radius square minus inner radius square. I hope you enjoyed watching this video and solving the exam with me. Thank you very much.